We've seen how energy can be transferred, transformed, and dissipated, and we've seen that in all of these cases, that important universal rule about energy applies, that all energy has to come from somewhere and go somewhere. So that meant that when we transfer energy, if we have 12 joules at the beginning, even after we move it around, we'll still have 12 joules, because all the energy has to go somewhere. Same thing with when we transform energy. When we change it from kinetic energy to potential energy, if we had 10 joules to start, we'll have 10 joules at the end, because all that energy has to go somewhere. And even in cases when it looks like we're using up energy, like when the energy of a hot cup of water spreads out to the room, it looks like that cup has just lost energy, but the room has gained a little heat. And so the total amount of energy at the beginning, 10 joules, has to be the same as the total energy of the cup and the room together at the end, 10 joules. So we've got this important rule. Now that you understand that, it's time to come back full circle to talk about global warming. Remember these two graphs? These tell the story of global warming. It says that over millions of years, the temperature of the Earth has sometimes been higher and sometimes been lower. We call that fluctuating, moving up and down. But today, things are starting to go up, and scientists have a lot of reasons to believe that it's going to keep going up. It all comes down to this next graph, which is about how much fuel humans have used. Well, for millions of years, we used almost no fuel, but again, today, fuel use is on the rise ever since the Industrial Revolution. And everyone agrees that our fuel use is going to keep going up at a faster and faster rate because of the billions of people who want to have better lives, bigger houses, more cars, and all of that requires burning fuel. Well, what does burning fuel have to do with global warming and energy? Let's take a simple example. When you burn wood, that's a source of chemical energy. So we'll draw that here. So we've got a chemical energy source of wood, and when we burn that, what's happening to that chemical energy? Well, maybe before you would have said that energy is used up, but now we know that can't be. What's happening instead is that that energy is being dissipated. So that means the chemical energy is transformed into thermal energy, and that thermal energy, or heat, spreads out into the environment. And eventually, once all of that chemical energy has been transformed and dissipated, the fire will run out. So we could say that the amount of wood can run out, but the energy itself isn't running out. It's only spreading into the atmosphere and the environment. The same thing goes when we talk about driving a car and gasoline. People might say, oh, well, you need to save energy, save fuel. Well, what does that mean if that energy can't ever really disappear? What it means is we need to save the useful forms of energy that we have. So for example, gasoline is useful as a fuel. And when we drive a car, what we're doing is we're using up that gasoline, and the energy from the gasoline, again, is turning into thermal energy and being dissipated to the atmosphere. So that heat is spreading out. The energy hasn't disappeared, just the opposite. The energy has stayed around as heat, but the gasoline, that got used up. Even when we use electricity in our house. So let's here draw just a lamp that's plugged in to an outlet. And when you turn that light bulb on, again, what do people mean when they say that we need to save energy? Well, that light bulb, in addition to shining out light, you'll notice that it also gets hot. It's spreading out heat energy. That's dissipation again. And where did that energy come from? Well, remember again that behind the scenes we've got our power lines that go back to our power plant. And in that power plant, they're burning fossil fuels. So when we say that we need to save energy, what we really mean is we need to save ourselves from burning more fossil fuels. Because when we burn them, we create heat here, we create pollution, and even this light bulb is dissipating heat as well. So the energy from the fuel has been turned into thermal energy, or heat, and dissipated. Everything we do that uses fuel is adding to the heat in our atmosphere, because all of that energy eventually gets dissipated. What does this mean for the Earth? Well, if you go back 200 years ago, before the Industrial Revolution, the Earth was a much happier place from an energy perspective. So here we've got our Earth. You have to excuse my map skills. There we go. And a long time ago, we had all these places where there were lots of fossil fuels buried. So maybe we have a lot of oil in the area that's Texas. We have a lot of oil in Saudi Arabia. There's some gas in the ocean. There might be coal in some places. And, we have a little bit of some clouds, some things in the atmosphere. But overall, we just have all of these places where there's huge amounts of chemical energy buried under the earth as fossil fuels, and nobody even knew about them at that point. Well, go 200 years later. What's happened? The earth is a very different place. So now, these places where we used to have all these fuels buried, so let's just draw this real quick. These places where we used to have fuel buried are getting emptied out. So now we have only maybe a little bit of oil left. We have some amount of gas left. We don't know exactly how much remains, but a lot of it has been dug up and burned. So that means as we burn these things, the oil, gas, and coal, we're adding heat, dissipating it into the environment. And that means that everywhere around the world that we're burning these fossil fuels, we're dissipating heat, and that's making the earth a hotter place. And so the result is that there's more heat altogether. But there's a second problem. These fires also, in power plants, when we burn these fuels, this creates pollution. And the pollution, it's mostly chemicals called greenhouse gases. These form like a blanket of clouds around the earth. So these are the greenhouse gases. That's like the greenhouse gas blanket, you can think of it. And what that means is that all of this heat that would be let out and dissipated by this burning of fuel, instead of just escaping into space, it's going to be kept in, because the blanket of greenhouse gases keeps that heat in. And so all of that energy that was being dissipated as heat, instead of escaping into space, it's staying with the earth, and the earth is getting hotter and hotter. Let's go back to these two graphs here. This is why it should be such a concern to see that our fuel use is going up, because we know that that leads to two things. That leads to more heat and also more greenhouse gases. And those things, greenhouse gases, and those are exactly the things that could lead us to this bad scenario of rising temperatures. So what can we do about it? Well, to reduce the amount of greenhouse gases put into the atmosphere, that means that we need to use cleaner fuels, like we talked about before. If we use fuels that don't actually release gas into release pollution into the atmosphere, that would be a little better. But even if we use solar power and wind power and electric cars, all those things still are putting heat out into the environment. They're dissipating that energy, because that energy can't just disappear. It has to go somewhere, and it's dissipated as heat. The only way to reduce that is just to use less fuel. And this is the big goal that we have as a species. Can we use less fuel? Can we use cleaner fuels? And can we make sure that the Earth of the future doesn't look like this? In the upcoming units, you'll learn much more detail about different kinds of energy. Our next unit is about kinetic energy, the energy of speed. So answer some questions after this video, and then get ready for a whole new unit on kinetic energy.